Small doesn't have to mean unimpressive. Although Mercury is at the bottom of the size chart in our planetary system, that doesn't mean that it doesn't have gripping structures and secrets on its surface. Luckily, we are now in the comfortable position of being able to marvel at the tranquil celestial body in detail without having to move an inch from our couch. So what do the breathtaking Mercury photos show us? Why does the furrowed surface resemble a cosmic Swiss cheese? And why do some experts believe that Mercury is not actually a classical planet? The Earth's diameter is 12,742 kilometers and is thus about 2.6 times larger than Mercury. In fact, the smallest planet in the solar system is only 4,880 kilometers in this category. But the distances from the Sun are just as different. While the average distance between the Earth and the Sun is still 150 million kilometers, the corresponding distance for Mercury is much closer. No wonder, since this planetary pipsqueak is, after all, the closest representative of our home system to the Sun. As a result, it's only 58 million kilometers away from our mighty giver of warmth and life. Conversely, however, this small distance also makes Mercury the fastest planet in the solar system. While our earthly home still needs 365 days to completely orbit our mother star, Mercury only needs 88 days for this endeavor. In detail, however, the small rocky planet does not describe a perfect constant orbit but follows a course that is shifted a tiny bit by the gravity of the Sun with each orbit. At first glance, you would think that such deviations would not have any major consequences. But in reality, they could one day even seal Mercury's fate. Because in fact, the gravitational forces acting on the planet could, over many millions of years, completely throw it off its orbit, causing it to either plunge into the Sun or enter the orbit of Venus or Earth. Fortunately, we have been spared such an unexpected planetary rendezvous so far. So we still have enough time and opportunity to take a look at the drastic temperature differences that occur on Mercury every day. Since Mercury occasionally comes as close as 46 million kilometers to the Sun, the thermometer on its day side climbs to a scorching 427 degrees Celsius. By contrast, it is much frostier on the night side. Here, temperatures can drop as low as 173 degrees below zero. These extreme temperature fluctuations are exacerbated by the fact that Mercury has virtually no atmosphere. This means that the Sun's radiation hits the planet's surface virtually unfiltered, which is why the idea of a manned mission to Mercury is currently still a long way off. And so it is that experts primarily rely on unmanned probes to take a closer look at Mercury. However, this has only been the case twice so far. To be more precise, only two space probes, Mariner 10 and Messenger, have ventured into the realms of Mercury. Although it has now been 10 years since Messenger thundered purposefully onto its surface, the good news, however, is that the time of waiting will soon be over. The Bepicolombo probe has been performing one Mercury swingby after the other for several years now and is scheduled to swing into orbit next November. But since Bepicolombo will not be the first space probe to capture the surface of Mercury on film, we can already enjoy numerous detailed insights into our planetary environment. The fact that Mercury, not only in terms of size but also visually, is more reminiscent of a classical moon than a planet becomes clear to us as soon as we take a quick look at its crater-riddled exterior. The fact that the furrowed surface consisting of rough dark rock is full of impact holes is also due to Mercury's weak atmosphere, in which not even the smallest projectiles from space burn up. What also immediately catches our eye in view of the countless craters are the many radial structures emanating from them. In detail, these are the traces left by the material swirled up by the collision as it ate into the planet's surface. In fact, we also find such impact relics on our moon. Against this background, the question inevitably arises as to whether it can really be a coincidence that Mercury's appearance is so reminiscent of a typical satellite. Well, some researchers answer this with a definite no and consider it more likely that Mercury itself was once a moon of Venus. No wonder, since Mercury and Venus are the only planets in the solar system that are not accompanied by a natural satellite. However, it's not yet clear to what extent this plausible hypothesis matches the celestial body's actual history. What is known for sure, though, is that the crater named Mina is further proof of how much a planet's appearance can change due to constant bombardment from space. The bright ray system that adorns the 15 km wide impact site also proves that the collision responsible for it occurred relatively recently. However, the currently still brightly shining rays will fade over time and gradually blend into the turbulent landscape. The largest crater on Mercury, Ludwig van Beethoven composed 9 symphonies and also managed to immortalize his name beyond Earth. A colossal impact crater on Mercury measuring 625 kilometers in diameter has been named after Beethoven, making it the 11th largest impact crater in the entire solar system. Aside from its astounding dimensions, however, the impact point differs significantly from its counterparts on other celestial bodies. After all, we look for the actual characteristic rings here in vain. Researchers estimate that Beethoven extends up to 2.5 kilometers in depth. In fact, the impact site is in excellent company. More precisely, this means that we find a few other craters in it, such as the almost 140 kilometers wide Bellow. Although Beethoven's size undoubtedly amazes us, it's not the largest impact basin on Mercury. That title goes to Planitia, a crater with an incredible diameter of 1,550 kilometers. Researchers assume that the asteroid that stamped this brutal testimony into Mercury's ground must have had an intrinsic diameter of 150 kilometers. While the imposing boulder was eating its way into the surface an estimated 3.9 billion years ago, the energy released must have been so enormous that it even swirled up the opposite side of the planet. Accordingly, the collision probably caused a 500,000 square kilometer area of terrain to break open there, forming huge mountain ranges up to 1,800 m high. Sometimes you have to look twice to see a planet's true face. While the 715 kilometers wide Rembrandt crater eluded the Mariner probe, Messenger identified the 3.9 billion-year-old impact basin in 2008, and thus also the 10th largest known crater in the solar system. But while the structures on Mercury's surface presented so far still bear a striking resemblance to comparable formations on other celestial bodies, the planet's outer side also harbors some formations that we don't find anywhere else. This also applies to some scarps, some of which extend hundreds of kilometers through the rugged surface and are known in scientific circles as rupes. Typically, these structures run in gentle paths through the craters and plains, and the longest of them bears the simple name Rupes Discovery. In detail, the corresponding step has an impressive length of 400 kilometers and, just like its smaller counterparts, it is the result of overthrusts of Mercury's crust. In the same breath, however, the objects also bear witness to the planet's astonishing past because they were most likely formed when the entire planet Mercury shrank a little. What also shrinks a little in some of us is the heart when we see a spider, and yet this was exactly the name given to the crater by the experts at Apollodorus before it received its official name. The reason why the crater was originally named after a creepy crawly is obvious. After all, the countless long furrows near the impact basin do indeed remotely resemble spider legs. The structure discovered by Messenger is located in the center of the so-called Pantheon Fossae, a large graben system in the interior of the Caloris Basin. However, it's not yet known whether the 40 kilometers wide Apollodorus crater played a decisive role in the formation of Pantheon Fossae or whether its location is ultimately just a coincidence. What we do know, however, is that the Tolstoi crater consists of several impact basins. These include 2 ring structures with diameters of 355 and 510 kilometers respectively and another incomplete ring estimated to be 465 kilometers in diameter. Although this crater is already many billions of years old, it still has an amazingly well-preserved ejecta blanket. This refers to the debris that was ejected during the collision and settled around the impact site. Now, the unusual, almost linear arrangement of the ejecta blanket of Tolstoi crater also suggests some exciting conclusions. Researchers estimate that the ejecta pattern has a controlling influence on those structures that already existed before the formation of the crater basin. What didn't exist before the formation of the crater basin, however, was Ernest Hemingway. And yet the famous American writer also lends his name to a structure on Mercury. And this is, how could it be otherwise, a crater again. This time, however, it is a 126 kilometers wide crater that appears significantly darker than its numerous counterparts. This is due to the fact that the rock in this region has a different mineralogical composition than the other surface structures in the area. And in the area around our video, there are now a few surface structures waiting for you to click on them. Just click the thumbs up and subscribe now to never miss a new video from us again. We'll see you soon.